Welcome back, everybody, to another episode of Tea with a Fantastic Researcher. Today, we are privileged to have Jen Wang joining us from Max Planck Institute and Saarbrücken Research Center for Visual Computing, Interaction, and AI, where he's going to teach us all about egocentric human motion capture and go beyond that a bit. Jen, we're very excited to have you with us and really, really looking forward to this talk. So the floor is yours, and yeah, we're happy to listen.
Okay. So thank you very much for the invitation of Haitham. And yes, so today I will talk about the egocentric human motion capture and beyond. And so in the very beginning, I will first discuss some background of egocentric human motion capture, why it's called egocentric human motion capture, what is egocentric human motion capture, and I will talk about three of my recent CVPR 2024 works. Actually, not in the first work, I'm the first author, and in the remaining works, I'm the second author. But they are all state-of-the-art egocentric human motion capture works recently published, and also after that, we'll talk about something beyond the egocentric motion capture because we would like to see how this method can be combined with some fancy ideas like large language models, robotics, and human motion generation models. Yeah, so let's get started. So we know that motion capture system has obtained large-scale success on multiple fields. For example, the human telepresences, the virtual reality, and the film productions. Especially like in the Hollywood, every day, a lot of people wearing such kind of motion capture suits to make films. However, this traditional motion capture system usually requires a motion capture studio, or at least a single external camera to capture the human motion. But this setup is quite restrictive for many post-estimation methods. Many post-estimation applications that require the person to be able to walk around in a larger space. For example, if you wear VR or AR headsets, obviously you do not want to always stay in the same place. So actually, there's a need for developing the human motion capture methods from the body-worn devices, especially like the VR AR headsets. So there are some methods that can estimate human body motions from the body-worn devices. One of the methods is by mounting the IMUs on the human body, just like what we can see on the left part. And this method, the problem is that this method have to bind the IMUs on the human body. It's not very convenient, and actually it will alter the natural human motions. Another series of methods is to mount front-facing cameras on the human body. But the problem is that usually you can only see part of the hand or feet from this camera, and most of the other part of the human body can only be guessed. So, and actually, there are also some full body motion capture functions in the state-of-the-art commercially available AVR headsets like the Quest 3. But the Quest 3 estimates the full body motions from the pose and 60 pose of the headset and the controllers in the hand. So they know nothing about how the hand can move in the human, how the feet is moving, and so obviously you can see it cannot get very accurate full body human poses. And so in response to this, yes, these are two pioneering methods that mounts a down-facing fisheye camera on the head or on the VR headsets. Yeah, from this camera view, we can see that we can observe most parts of the human body, and we will be able to capture very accurate human motion from it. However, this setup is generally good, and but it have some
Jen,
problems. Okay.
just to understand, so you are saying that the idea is that you want to do this egocentric capture, but you want to have a camera located somewhere where you can observe the whole body so that you can recover the pose and so on?
Yes, because if you have, for example, one camera located on the top of the screen, if I move outside of this view of the camera, the method will definitely fail, right? And especially in the VR AR applications, you definitely want to wear the device and go everywhere you want.
I
So
see.
actually, this setup is not an optimal setup for especially the VR AR applications.
Right. No, but this is very interesting because you want to take this beyond the lab environment, right? Because typically in the lab we locate all these cameras and so on, right?
Yes.
But this is not practical. So what you want to do is you want to extend that, right, to make it more practical. So then you want the camera to be egocentric and moving and so on, right?
Yes, that's true.
Okay. Okay. Yeah, makes sense. Okay.
Okay, so yeah, actually, this is already some topics that is extensively researched in the recent years, and actually in the CVPR 2024, the Meta is hosting a challenge on the egocentric motion, full body motion capture. So actually, this is a growing field that grows very fast and have a lot of potential applications. So let's continue. So this setup was quite good. So, I mean, the down-facing fisheye camera setup is very good, but it have some problems. One biggest problem is about the lack of data sets. Because it's a fisheye camera, the camera have some distortions, and also it's mounted on the head of human body. So basically, you cannot get such kind of data from anywhere else. So that's the first problem. And the second problem is the self-occlusion. So this is a very common problem for the egocentric motion capture, because you device is always mounted on your human body, especially for the computer vision algorithms. You can maybe in a lot of times you cannot see one part of your human body. For example, in this down-facing fisheye camera setup, you can see that the lower body, the feet, is partially occluded. Yes, the third problem is the fisheye distortion, and it's also easy to observe that the distortion on the edge of the fisheye camera is more serious than the distortion on the center of the fisheye camera. So that's three challenges that hinder the process, the improvements um, of this development of this field. So
And oh, sorry to interrupt, but these problems are not covered with the Ego 4D dataset, for example, right?
yes. Eagle 4D dataset is a perfect dataset, but it does not consider anything about the human motions. It's a pure human scene interaction dataset, but actually there's recently an Eagle Exo 40 dataset.
Mhm, mhm, mhm.
Yes, very recent Eagle Exo 40 dataset, and it contains the ground truth human motions. Somehow it can somehow solve the first problem because Eagle Exo 40 is a very large scale dataset. But always the self-occlusion is always a problem for any computer vision-based egocentric motion capture setup, and the fisheye distortion is something that this specific setup have because we are using the fisheye cameras.
I see. So even with the existing data sets, we still have to solve self-occlusion problem.
Yes, yes, yes. So this is something I will discuss some later in the beyond egocentric blah blah blah. Okay, so here are some examples to demonstrate that. So here you can see that actually in this image, the white area is where the human body is occluded, and the black area is where the human body can be seen. So you can see that the most part of human body is actually white, and also there's a scale issue. Like if you put your cameras on your head and actually the feet is quite far away from the camera, but your upper body is quite close. So actually the feet, the lower body part will take a much smaller pixels in the egocentric camera view. Okay, this is an example of the fisheye camera distortion. You can see here there's a table, and the edge of the table is distorted, is bent. So this is not optimal for the neural network to learn the representations. So yes, so inside of this, in the recent CVPR 2024 conference, we have published three papers. Yes. So the first paper aims at to solve the two problems: the the self-occlusion problem, and also the fisheye distortion problem. So firstly, we have the fisheye VIT. So it's basically firstly undistort the image patches, and then to send it to the transformer, and then after we extract the feature tokens, we put the feature tokens in the pixel line 3D heat map to regress the body joints. And also we have the hand pose detection method and hand pose estimation method to get the hand poses. After gets the hand and body poses, we use diffusion-based whole body motion refinement method to finally refine the initially estimated human motions. So yeah, so let's first look into the fisheye VIT parts. So traditional VIT, we know that. So we firstly crop the initial image to several small patches and send these small patches to the transformers
Glenn,
first.
sorry to interrupt again. Can you go please one slide back?
Mhm.
Yeah, this was too fast for me. Could you maybe just go slowly through each step here and why we need it?
Yes. So the first step is fisheye VIT. It aims at solving the distortion of the fisheye camera. So basically, yeah, I will explain each modules later. We have the detailed explanation later. So the first step is to eliminate the distortion issues, and the second step is how we regress the 3D body joints in a very simple way. And the third step is about estimating hand poses. But the hand poses, I mean, is good for the detailed representation of the human body. And also the fourth step is also a very important module in our method. It's use the diffusion models as a motion prior to refine the initially estimated human motions. So these are four modules of our method, and yes, so I will explain the first, the second, and the fourth in detail because the third one we are just using some publicly available method to do that.
Yeah, and which one of those handles the occlusion, like the self-occlusion?
The force actually, the force is
Okay.
yes, it's because it's first utilize the temporal information, and also it's utilize the uncertainty information obtained from the human motion capture network. Yes, we'll explain it later.
Okay.
Yes, so the first step is the fisheye VIT. So we know that traditional VIT, in the traditional VIT, we firstly crop the images into several parts and to embed it and send it to the transformers. But obviously we can see that in the different patches, the distortion is quite different. In the patches that's close to the edge of the image, the distortion is serious, but in the center, distortion is better. So what we do is that we firstly project the images into the into the surface of a hemisphere, and we try to undistort the fisheye image on the tangent plane of this hemisphere. Yes, so this is a very common practice of the undistorting the one small part in the fisheye camera. And one question is that why we cannot undistort the whole fisheye camera? This is because the fisheye camera covers a very wide angle or wide FOVs, field of views. So if you simply undistort it, the images will be extremely large and it's not practical at all. So after undistorting the image patches, we send it to the transformers and get the feature tokens. Yes. So here I show some undistorted image patches and how this image patches is moving on the in the view of the fisheye camera. So you can see on the left side, there's no issue of the distorted chairs, desk, something like that. Yes, after we get the image, the feature tokens from the fisheye images, we use pixel line 3D heat map to regress the 3D body joints. So the basic idea is that we use several convolutional layers to convert the outputs image patches into the 3D voxel space. So in this case, the XY axis of this 3D voxel space is actually the UV axis of the image plane. So that means we can correspond very easily from the one voxel in the 3D heat map to the 2D pixels in the image. So in this way, after that, we use a soft arcmax to get the 3D body joints, and we can supervise the learning of the transformer very easily. Yes. So the last part of our method is called diffusion-based motion refinement. This is the place where we solve the self-occlusion issue. So basically, from the 3D heat map, we can not only get the 3D body body joint locations, but also we can get the uncertainty of each joint. For example, if a joint is occluded, then the uncertainty on that joint will be relatively high. If a joint is clearly visible, and the uncertainty will be quite low. So in this way, we use a classifier-based guidance in the diffusion-based method. So in each step, the diffusion denoiser generates X0. X0 is unnoised human motion. And we use a classifier-based guidance to make sure the X0 is close to the estimation of the from the network X0 hat here. But we also said that we need to control it by using our uncertainty, by using the uncertainty on each joint. So in order to do that, we have the weight controlling factor here. That means if the uncertainty is very high, that means the weight will be quite low. That means this joint will be generated by the diffusion denoiser, will be generated by the diffusion model. But if the weight is if the uncertainty is low, then the weight should be high, and the X0 will rely on the estimation of the body pose estimator. Yes, so we use this function to control the weight, and U is actually the uncertainty value here. And if you draw this function, this will be something like the softmax function. That goes that if you increase the U, that means the uncertainty increases and the weight will be decreased.
Yeah, can you say a bit more about this U? So where does this come from? I'm a bit confused.
Yes. So this U is actually come from the 3D heat map because it's a heat map, right? So it's basically estimates the Gaussian distributions, something like a Gaussian blob in the 3D space. It's a very common practice to do the pose estimation either in the 2D pose estimation area or in the 3D pose estimation area. So after we get it, we find the maximal value corresponding to this joint, and the value itself is it can be viewed as uncertainty, and the position of the maximal value of the Gaussian blob is actually the position of the body joint.
I see. Okay, and then using this uncertainty, you make your diffusion model focus more on which joint it should create.
Yes, we're more focused on the low uncertainty joint I have created, low uncertainty joints.
Okay.
So
wait.
yes, so actually it's
Yeah.
no, I'm sorry. Focus on the high uncertainty joints. If you can see it, it's basically to remain the estimation of the joint positions for the low uncertainty joints, but generate the positions of high uncertainty joints.
Yeah. Okay, understood. Yeah, exactly. Yeah. So it's like we're uncertain, then we will use this generative diffusion model to fill it in. And if we're
Yes,
certain, we just don't do that as much. Yeah. Okay.
yes, that's true.
Okay, cool. Yeah. Okay, yeah. And uncertainty means that in this case you have high occlusion, essentially, right?
Yes, basically.
Okay,
Yes.
okay, got you. Okay, understood. Thanks.
Yeah, so this the method parts of our paper. And here are some quantitative results, and you can see that the results is quite better than all the previous state-of-the-art results on the available real-world dataset or synthetic datasets. And also, these are some realization results. You can see that from this camera, the estimate motion is quite accurate, and even there's a very strong occlusion, like what we just see, someone is squatting on the ground. You can also still get very highly accurate human motions. Okay, so let's
This is super cool. This is really nice.
okay. Okay, so let's go to the second paper on the 3PR this year. So yes, the second paper somehow solves the first problem, like the dataset problem, and it's called Unreal Eagle 2. From Unreal Eagle, you might think about this is something related to the Unreal Engine, but this is true. So one very biggest contribution of this paper is that we generate a very large scale data sets that comes with ground truth annotations.
Jen, sorry again, but I just want to ask you one question about the work before, if that's okay.
Okay, no problem.
So it's very interesting, but can you go? Yeah. So what guarantees in your architecture that you have valid human motion? Like there's no physics anywhere, right? Like what hap
Yes.
like how does it happen? It's just from data?
Uh,
Or- Yeah.
Yes, it's basically from data. So here we have a diffusion-based whole body motion refinement that's
Mm,
actually learns a motion prior. The diffusion model is actually only learned from the AMAS human motion data sets. It captures the human motion prior. It's a large-scale human motion data set, AMAS, right? So it captures the human motion prior. So the generated motion from the diffusion denoiser is always in the in the domain or in the distribution of the plausible motions. So you can basically guarantee that the motion is plausible. But of course, even the state-of-the-art diffusion models for the human motion generation cannot guarantee that the generated human is always physically plausible. So actually, recently there are some methods to deal with that, the NVIDIA's physics diffusion to solve this
mm,
problem, and also there are some other methods that can use, for example, PD controller to guess the human motions. They are those methods consider the physics in the human motion capture period. But in this method, we do not consider any physics-based terms or
right.
considerations.
Okay, but I mean, your method is orthogonal, no? Like, for example, I can replace your diffusion denoiser by NVIDIA's one, right?
Yes, so this is why I like this, because this all of the methods, including the fisheye VIT, including the pixel line 3D heat map, everything is orthogonal. So it's modularized, so you can replace every module with any other thing that you like. Of course, you can replace physics-based refinement method here. You can also replace anything
Mm,
you want here.
mm, mm, mm. Yeah, makes sense. Yeah, that's why it's cool. I agree. Yeah. Okay, cool.
Good. So yeah, so go to the next project. Yeah, I will shortly introduce this project. So this is the first contribution of this project is to capture is to generate a large-scale synthetic egocentric data set with Unreal Engine. Yeah, so basically it's I'm sorry, why the video does not play. Okay, so it's basically um, so here the target is to capture the human motions from the stereo fisheye cameras. Apart because in the last project we use one single down-facing fisheye camera to capture the human motion. Here we use two of the fisheye cameras mounted on the glasses of the human and we wear mounted on the glasses, and we wear the glasses, and we use views on the right side, like we can see on the right side, to capture the human motion. Yes. So we firstly use the Unreal Engine to generate very large-scale stereo images with rich annotations. Like we know the ground truth 3D skeleton of the human body, we know the mesh of the human body, we know the surrounding scene geometries and surrounding scene semantic annotations. And based on this, we use Unreal Engines to render the fisheye images, and we can construct a large-scale data set with 1.25 million stereo images. And yes, and after that, we also have some methods to tackle the to get the human motions from these stereo cameras. So here we use several modules. We use 2D post estimation module to 2D post estimation modules to get the 2D joint heat maps, and we also use the human body segmentation modules to get the segmentation of the human body in the egocentric image. And by using the human body mask and the original stereo view inputs, we can reconstruct the 3D scene mesh with the structure from motion method. And recently there are some state-of-the-art methods to reconstruct the 3D scenes from the multiple views, like the nerf or 3D Gaussian splatting. But here we use our structure from motion, very old method, to get it. And from the mesh, we render the depth images. We can get the depth images, and but for some cases, the depth images are not plausible, and we just remove that. And afterwards, we take the 2D joint heat maps and depth images together into the transformer decoder, and we use the features from the 2D pose estimator as feature tokens, the input tokens to the transformer decoder. And from the transformer decoder, we consider the spatial correlation and the temporal correlation between the stereo video inputs, and we can regress the 3D body pose in a very accurate way. Yes, so this is a basic framework, and here's some quantitative results. We also outperforming all previous methods from the stereo cameras, and also this is some demonstration, like we can wear this stereo camera and we can do any type of motion. So on the right bottom we have a stereo input, and on the right this is 3D virtual character animation with only the 3D poses estimated from our model. Yeah, so you can see the results is quite good. Yes, and also and also the next project is about Event Ego 3. It's called Event Ego 3D. And this is also the egocentric human motion capture project that we mount the event camera on the head to capture the human motion. So why we want the event camera? Event camera is actually some special camera that can censor the light changes, brightness changes from the view. The best of the event camera is that the first it can the FPS is extremely high. So it's basically it can capture the images with arbitrary FPS, arbitrary high FPS, like 3000 FPS is even possible. Another best thing about the event camera is that it can work in a very dim light. For example, if the light is very dim, maybe for the normal RGB cameras, the exposure will be quite bad. But for the event camera, there's no such kind of concerns here. So here we use the egocentric event camera stream as the input to get the 3D human pose estimations from the egocentric camera. So basically, the methods is like we use a simple encoder-decoder network to regress the 3D heat map, 2D heat map, and we use a heat map to 3D lifting network to directly regress the 3D body poses. Here we have one problem is that sometimes the human body does not move. So that means that if the human body does not move, the event camera will not give any signal because it's detects the change of the brightness. If the human body does not move, there will be no change of brightness, and there will be no changes in terms of the there will be no changes in the event camera view. So in order to do this, we have to consider through a very long periods of the history of the event camera informations. So here we have the residual event propagation module, and that is we take the features from the network encoder, and we firstly segment out the human body parts from the input events, and after that we put into the frame buffer. So here in the frame buffer, we store the history of the human bodies in the egocentric views, and the buffer the signals in the buffer will decay as time goes. So actually, if for example, if sometime the human body does not move at all, and it can still infer the human body pose from the frame buffer. Yes. So this is some results of this method. So you can see under the very fast motion and the very dim lights, the human pose estimation is still not bad, I like to say, because the event camera is very good for these two cases. Yes. So this is a third paper I would like to discuss in this talk. Yes, and
Oh,
next
sorry,
part.
sorry. Can you please go back to this slide? Yeah. So I'm a bit confused about the results because like let's say the current result here on the left, right?
Mhm.
Uh so is it accurate actually? I mean because at
No, it's not very accurate
Hmm,
because currently the event camera is still this method is still in its very early stage, I like to say, and
hmm,
also the event stream is not like the RGB stream. It does not contain that rich information. So, for example, you can see the event stream here is you can somehow see
hmm.
the human motion, but it's it does not contain quite much information about it. So it's quite challenging to capture the human motion from it.
Yeah,
So
yeah,
it's not very accurate, but it can work under very extreme situations, like the fast motion and low light conditions.
yeah, I got you. Okay, understood.
Yes. So do you have any question about these three papers?
Yeah, I just want to ask more about the buffer, right? Like the buffer, can you is like a memory? It's like a
Yes.
memory you give or yeah.
It's actually something similar to the um, something a little bit similar to the features something little bit similar to the latent space of the recurrent network.
Hmm,
It's obtained from the views, and it actually decays as the time step goes. But the frame buffer is actually it can be viewed as an image, and during the inference we take the current frame and frame buffer together into the encoder decoder network.
but I mean, why not like a transformer and then context window decides what you take, or this is different?
So actually, there's two things we need to consider here. The one
Hmm,
thing is that we do not know. For example, as in the example I explained before, if the human body does not move, there will be no event signal at all. So in this case, we have to consider the features, the input events from the longer history, from the history which is far
hmm,
from this current time step. This
hmm,
is first thing that maybe transformer will not be able to work. And another thing is that because we are aiming at some real-time human motion capture methods. Because the event camera can actually capture the human motion in a very high FPS, like for example 300 FPS or even 1000 FPS.
hmm,
So we are aiming at to at least real-time human motion capture here. So actually it's not a very good idea to use a transformer to do that, because transformer one problem is that it consumes quite a lot of resources, computation resources, and second problem is that it's not very easy to make it autoregressive. Like yes, of course, we know that there are autoregressive models, but it's even if you want to transformer to be autoregressive, it also consumes a lot of computer resources. It's not very good idea to make it real time. So
Mm,
that's why we use a frame buffer rather than some temporal models like the transformers.
I see. Okay. And do you know these state space models that have been recently developed?
Yes, I have heard of those, but I have not looked very deep into those methods.
I see. Okay, got you. Yeah, no, this is very interesting. It's just that I was thinking whether state space models could work here. And in fact, it's interesting whether we can apply your idea of a buffer, frame buffer to language, for example, to reduce some of the same similar problems we might have in language.
Okay. Yes, maybe I have no idea, but if, for example, if the state-based method like member, I think, can be used in this in the human motion capture area, that will also be quite interesting because
Yeah.
currently, we are all still using some very old method like RNNs or just inference from the single views for the real-time applications. And if the states-based method can consider the temporal information, but does not harm the
Mm.
real-time performance quite badly, and I think this will be a very good choice to do that.
Yeah, okay, interesting. I mean, I think Mamba has been transformed to Vision recently, like there was a Mamba Vision or
Yes,
something. Yeah, I
yes.
see. Okay. Okay, yeah, got you. Thanks. This makes sense.
Okay, so maybe let's continue. So we know that we have already introduced several state-of-the-art methods from me, and also there are tons of egocentric human motion captures from other groups, from other people, and they are all quite good. But what will be the future? What is on the horizontal? So here I choose several aspects to discuss, including the large language models, robotics, and the human motion generation, human object interactions, and scene understanding, and egocentric avatars. Yes, so first thing I would like to talk here is about the human motion generation. So actually one observation we recently realized is that the condition human motion generation is actually equal to the human motion capture. It's like on the right image in the right video, on the right, I'm sorry, on the left video is some example of the state-of-the-art human motion generation model, motion MDM. So actually, it can generate the human motions conditioned on the text input. But on the right is my method to estimate human motion from the images. But if you think my right method as some human motion generation method, but only conditioned on the input images, so that is also that these two things are the same, right? So yes, so the difference between the human motion generation method and the human motion capture method is only in the conditional modality. That means human motion generation method currently conditioned on the text description, and the motion capture method is conditioned on the images. So, and also, we recently we all already seen that okay, there's a very good trend of how to combine the human motion generation method into the motion capture domain. Like in this previous paper, we have the diffusion-based whole body motion generation method as a motion prior to refine the method to refine the human body poses, and also we have the humor methods that captures 3D human motions from the from the VE generative models. So actually, uh, there's an idea like if we can use the one single whole method that's for generating the human motion that accepts the different modalities, like the text modality and the image modality and other types of modalities as input, right? So this will be a universal method, not only for the human motion generation, but also for the human motion capture. So we can leverage the best of these two different domains and combine them together, and maybe we can get best of them in the common by using one single model. Yes. So is it possible? Yes, definitely. I would like to say so. Recently, there's next we comes to the motion capture and large language models, because large language model is also to consider as a generative models here. So one example is a very recent post-GPT paper. It's called "Chatting About 3D Human Poses." So basically, it takes the text description and the image information into the vision language models, and it is able to, apart from describing what is happening in the image, it can also get the simple body models, that is the human body poses from the images. And um, by using such kind of large language model or large language vision models, we can leverage more modalities than simply the text and the images. We can, for example, use the IMUs, we can use the surrounding environments, and we can get more things, more outputs than only the single view 3D body poses. Like we can do the human motion predictions, we can do the human motion high level understandings, we can do the human motion captures, and so on. So I think this is a very interesting direction that will happen in the maybe recent 1 year. That is how the human motion capture method can accept different modalities, and how we can make the motion capture method very large and can work not only on the human motion capture domain, but also the human motion prediction and human motion understanding domain. So I think this is this LLM stuff and human motion generation stuff are actually very interesting stuff that can be explored in the recent years. And also a very good start to do this is actually from the egocentric views. I also mentioned the Ego XO40 dataset. So actually, this dataset is a very good dataset, very large scale dataset, and a very high quality dataset that contains the images, the 3D information of the surrounding geometry and the motion of the headsets, and also the rich description about what the human is doing in the environment. And also it contains lots of semantic annotations of the environment and semantic annotations of the human motions and blah, 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 full of different types of the annotations. So I think this will be a very nice place to start exploring this, to start exploring the relationship between the human motion generation, human motion capture, and large language models. Yes. So, and the next part I would like to discuss is about the scene understanding and the human object interactions. So we know that the egocentric camera is mounted on the human body, so it actually works. So it actually moves around as the human body moves, and it really can see what people's eyes can see. So one very interesting task to do is to understanding the human object interactions, like in this Arctic data set. So it's have an egocentric video that looks into the interaction of the human and object, and we can understand the human object interaction from this data set. And also there's a recent 3PR work that's using the moving hand-mounted camera to reconstruct the scene geometry, and using the scene geometry to constrain the human motion capture task. So it's basically egocentric motion capture with a scene geometry awareness. Yes, and actually this is also quite promising direction that is currently intensively researched, and also there's there's a very big problem behind is that still for the scene understanding and the human object interaction task, we need to collect some data set. But we know that collecting such kind of data sets with this very special device is quite challenging because the scale will be quite limited. So one question is that, is it possible to understand this the scene information and human body interactions in an unsupervised way? Because, for example, if we wear this egocentric camera and we wear it for the whole day, like it can generate very, very large scale data sets from the only one device. Like if we wear it for like 12 hours, it will generate 12 hours of the videos. That is already quite large scale. So I wonder, actually, I'm wondering if it's possible to leverage such kinds of very large scale unsupervised data to learn something from it. So this is definitely might be a very interesting target to do
So
in the egocentric domain.
yeah, I mean, it's interesting what you mentioned. I can tell you that there is work on this that has been done using these things for robotics. So what they do is they take a lot of these videos, and
Mm-hmm.
then from unsupervised way, they try to learn a reward function
Mm-hmm.
for the robotic downstream task, right? So the papers include something called value implicit pre-training,
Mm-hmm.
which is tries to implicitly learn a value function from unsupervised videos, including Epic Kitchen, actually, and
Mm-hmm.
also Ego 4D.
Mm-hmm.
And then the idea there is they want to see if we can learn some reward function for control essentially later on,
Mm-hmm.
right? So definitely, I think there is a possibility. However, what would you like to learn from this type of data? Like you want to learn contact points, interactions, or what would you like to learn?
So actually, there's definitely a lot of possibilities. So one thing that can be learned is that, for example, the contact points is definitely a possibility, but contact points need some rich annotations. But one thing is that we can learn what will be the next step.
Mm,
So,
mm,
for example, if we do the kitchen, we cook something, and as we cooking, and for example, we have models and see what I'm doing, and say, okay, next step, you should, for example, put the egg in the plate and do the other stuff. So I think this might be a good way to do that in unsupervised learning methods.
mm, mm, mm. I see. Okay, yeah, makes sense. Okay, interesting. Yeah, yeah. But I mean, couldn't this be covered by just the text? Or not really, because maybe you need to annotate every goal
Yes.
change or something. Yeah, I think. Yeah.
Yes, that's true. Because in this way, you barely need any annotations, even the text annotations. So you
Yeah.
can get those very large scale data by just wearing this egocentric cameras on your body.
Yeah. Yeah, it's interesting because you also want to see if goals change, right, in the
Yes,
scene. And then the switch in the goals is like the next step that can happen, essentially.
yes.
Right. So you want to abstract a goal, let's say. Interesting. Yeah, okay. Okay, cool. Yeah, got it. That's cool. Okay.
Okay, so like Epic Kitchen stuff, and also the egocentric motion capture and robotic stuff. One thing that is happening recently is that, as you mentioned, is how to make sure the physics possibility of the estimates human motions. Here, this paper, also the CVPR work, can capture the human motion in the physics simulating environments. It's actually in the ASEC gym, and it's basically using how to. It's basically firstly capture the human body joints and then simulates the human body joints in the virtual environments, so physics via virtual environments. Um, I'm sorry. Okay, so this is another example. Here, so you can see it's able to control the robotics motion based on the human motions. So basically, this might be some also quite be interesting for the egocentric task. Like if you can, for example, by wearing the headsets, you can understand what's you're doing, or what's the head motion or the full body motion. And by using that, you can control, for example, robotics even. So this is a very interesting task. And the final task we are currently working on is called egocentric avatar. For example, recently we know that there's quite a lot of 3D generative models for the human avatars. It's like by yeah, taking the human motion as an input, we can drive the avatar of the human body, realistic avatar of the human body, and make it move in the virtual space, and we can render in a normal views. So basically, we can also do the very similar things in the egocentric domain. For example, we can understand the human's motion from the egocentric images. For example, for my down-facing egocentric camera, we can also understand what the human body is wearing, like what type of clothes, what type what color tones of the human skin, something like that, and the appearance of the human body can be obtained from the egocentric camera. And from this information, we would be able to reconstruct and drive the motion of the realistic human avatar. Yes, and this will have very wide applications like the human telepresences. Yes. Okay, so I think that's most of the stuff I would like to discuss today. So today we firstly introduced 3 papers that related to the egocentric motion capture, and also I have discussion some future directions that can be explored very recently about the human motion capture. Yeah, so that's it.
Amazing. Thank you so much. This was very, very interesting, actually. Cool. Yeah, I find this very exciting direction, especially when you talk about the LLMs and the robotics. I think these are pretty
Mhm,
cool. I like this like teleoperation setup you have.
mhm,
It's pretty awesome actually.
mhm,
Right. So I asked most of my questions during your talk,
mhm.
but I still have more like general questions, right,
Okay,
to
no
ask
problem.
you. So where do you think this field is going? So what's your dream from this field? What is the ultimate application you would like to get from?
Yes. So I think obviously the AR/VR headset is one applications, but I think I'm sorry. The most wide application is something called personal copilot.
Mm,
It's like, for example, if you wear the glasses on your head, on your body, and you have, for example, camera, several sensors on your glasses, you'll be able to makes a perfect copilot for everyday activities. So what we'll do next? So what is your plans? What is planning to happen, and what's should be what's for example, if you uh, do the how and like if you're driving, it can tell you where should you turn, and also if you're doing the procedural setup, it will tell you what should be do for the next step, something like that. So I
mm.
think maybe the ultimate application is not in the entire entertainment area, it's rather in the Copilot area.
Copilot. I say, okay, interesting. Yeah, and you think this copilot can also happen with like humanoid robots as well?
Yes, definitely. And also, as I said, apart from the Copilot area, the embodied AI is also very important applications. For
Mm,
example, we know that human body can vary it can give advices, and so the robots can also vary it, can also have the sensors on the robot body
mm,
itself,
mm,
and
mm,
can provide suggestions like the high level plannings, like what should be done and what should be avoided for the robots. So actually, this is also a heated topic about is it possible to combine the egocentric vision and the embodied AI?
yeah, I see. Yeah, because today the egocentric vision in embodied AI is relatively simple, right? It's more just a
Mhm,
camera on the arm,
mhm,
typically. If we have a robot arm, and then there was a recent paper I think which was pretty cool from Georgia's team in Darmstadt. I think they were trying to combine exploration and egocentric view. So the idea was I want to grasp an object,
Mm-hmm.
and I want to, move my arm such that I get enough visual information,
Mm-hmm.
so that I know, how the object looks, so I can grasp it, right?
Mm-hmm.
So now this is interesting because some people are also trying to automate that with nerf, like
Mm-hmm.
trying to do that nerf. But what you are suggesting, I think, is a step further than this, right? Because you're
Yes,
saying
yes,
you can say I can render much more complex situations, much more complex scenes,
yes,
and make the robot wear these. It's interesting, I think.
yes,
Yeah, very cool. Awesome, man. Yeah, I mean, amazing work. This is pretty awesome. Well done. Yeah, love
yes.
it.
Thank
Right. I
you.
still have one more question. So we
Mm-hmm.
ask everybody this. I mean, feel free not to answer, but
Mm.
we have a lot of problems today with the review process in conferences, right?
Ah,
Uh,
yes, of
in machine
course.
learning. So how has been your experience? And can you say a couple of things about that?
Ah, yes. Real process was actually I have one example. It's I just several months ago I finished my CVPR review, and
Uh,
there's one paper that only one person, that is me, who submitted the final ratings. S-
oh,
I mean, those reviewers are not responsible at all.
yeah.
So one thing I would like to suggest is that we just kick out those reviewers that is not responsible at all. And because they are basically wasting our times. Because if the rebuttal is submitted and if you do not get any responses, so the AC will have a very hard time to read and review and everything. And it's not a fair process both for the ACs and also for the authors of the paper.
Yeah, I
Uh,
agree.
yeah, but I'm personally quite lucky, and I got very responsible reviewers, and very even though my initial rating was quite low, but after my rebuttal, and I convinced them, and they higher my rating, so that is good. But for some of my colleagues, they even got the wrong reviews. Like the reviewers just copy the reviews for another paper to this paper.
Oh,
So, so
wow.
after they see the review, they are quite, they do not know what to say because, it's irrelevant papers,
It's
right?
not our paper. Yeah.
Yeah.
Wow.
So actually, currently, I mean, the reviewing process is like crazy. Like, you will see a lot number of unresponsible reviewers. I do not
Mm,
talk about their competence. Like some reviewers does not have the level of review other people's paper. But
mm,
as long as they take the responsibility for the review of the paper, they all good. We can find a way to convince those reviewers about their understanding of this field or how to review a paper or blah blah blah. We contact AC for that. That is not a big problem if the reviewer is not capable of doing the
mm,
correct reviews. But
mm.
if they do not take the responsibility, I think they should be directly wiped out from the list of the reviewers.
Yeah, no, I agree with you. However, the problem is a bit more complex, right? Because
Hmm.
we have so many submissions and then we have
Hmm.
so less reviewers. I think the reason why we are here is because of this, so many submissions, so less reviewers. So if you kick out reviewers, which you should
Hmm.
do,
Hmm.
then there's more pressure on the system. You know what I mean?
Yeah, yeah, actually that's true. So, but that's also mm, makes pressure on the reviewers. If you announce that you will be kicked out if you do not take the responsibility, and every reviewers will not do that, right? They are afraid of them being kicked out. This is like the idea like open review. Like in
Yeah,
the open review, because you know that your review will be open to everyone, so you'll be very careful when you write it. So I think
yeah.
even for not no open review conferences, this should be able to work. Like this
Mm,
will be a threat, right? Reviewers
yeah.
will be afraid of themselves being kicked out.
Yeah, you're right. I mean, if I think about the review process today, there is no
Hmm.
accountability, right? Like if I write a bad review, that's it. I
Hmm.
wrote a bad review. Then what happens? Nothing.
Yes,
Like
that's
uh,
true.
like I believe if there's a place where I can get kicked out or even my name gets known, reputation can get,
Yes,
then maybe people will do a much better review.
yes, that's
Um,
true.
So that's on the reviewer side. However, I also think on the author side there are problems.
Mhm.
Like it's, and I don't think it's the author's problems because we have this concept of publish or perish, right? Like that's the problem, I believe, because you want to more publish more, publish more, publish more,
Yes, yes,
and
that's true.
that's really not how science should be from my point of view. Like you should only publish what is good or what's useful, and when you have something to say,
Mhm.
yeah, I don't know. Like it's a messy process from both sides, I think.
Yes, but actually, I think it's hard to say what is useful before it's finally seen by most of people in the area, right?
That's
You
also
know,
fair. I agree. I agree. But that's why like maybe crowdsourcing this might make sense. So first, you might come to a place like this, give a talk about your work,
hmm
and then there might be like a voting mechanism to say whether this work should go into a review process or not, And then
um,
based on that, but then here, then the problem with my idea is that the qualification is weird, right? Because
yes, that's true. That's true.
yeah, but maybe each community can do that. Like that's what I mean, like somehow maybe each community will get experts of computer vision, and then they will actually decide whether to go or not to go in some fast way, and then
hmm
see from there what happens, right? uh
Yes. Yes, but this will also have a problem if you decide what's whether this paper is eligible for review in a fast way. Maybe some really good paper will be simply
Agree.
rejected. Yes.
Yes.
So
It's,
actually, recently there's a trend in the research domain. It's like no one will care more about how many paper you publish. It's more people are more caring about the impact of your paper.
impact. Yes. Yeah. Yeah.
Yes,
Yeah.
that's true. So if you really have a really good paper, even you do not publish the paper, as long as your paper is really good and really values quite much, and the impact of your paper will goes up.
Yeah. Yeah.
So that's a quite good rewarding for the researchers to do impactful papers,
I
not
agree.
to
Yeah.
to do high quality research.
Yeah, I agree with you. I mean, it's until companies and faculties start hiring people based on impact of work, not just number of
Yes.
work, right?
Yes, that's true.
Like I think things will change. Like if I value the quality, like you can have one paper from your PhD, but it's
Mhm.
so impactful, then that's good enough for me. And
Yes.
but you can have like 10 papers in your PhD and none of them are impactful,
hmm
then what's the point, so
Yes,
so
that's
it's
true.
it's it's really interesting because if we change the mentality of how we hire people, not based on quantity but based on quality,
hmm
maybe the whole process would become slower and then people will deliver more high quality work.
Yes, that's true. But this will also have down effects, like people will focus on the more impactful areas, not
Yeah,
for
not
the
everything will be yeah, that's
yes,
correct.
yes, yeah. Not everything will be perfect. That's true.
Yeah, yeah, you're right. It's a hard problem. It's just really hard for
Of
me.
course, of course.
Awesome, man. All right. This was fantastic. Thank you so much. I mean, really, it was great to have you and to speak to us. This was pretty cool.
Yes, thank you very much for inviting me, and this is very cool opportunity to discuss my research and my ideas about this area.
Thank you. Yeah, and with this, I would like to end this another episode of Meti with a Fantastic Researcher. So, to all our audience, please like, share, subscribe. And if you have any questions to Gian, please write them in the comments below, and then I can try to relay to him, or he can see them and then answer. So, thank you again, Gian. And yeah, hopefully, we will have the chance to talk in more details soon.
Okay, thank you very much.
Thank you.